All right, so day 5 of the final exam. This is the last one. And let me write down, for number 41, let me write down a definition for you guys. Okay? So, if you are given a term, now that term can be just one number, one letter, or a number and a letter. So you can notice right here they put 25y squared. That's what they gave me as A. If you have that to a fractional power, so I'm going to put P over I. Okay? The reason why I use the P over I is because I want it to mean something to you. The P is power. The I is index. Index is for radicals. That means that you can rewrite this two different ways, okay? One way you can write it, the more popular way, is like this. That's the more popular way. There is a different way that you can write it, which is like this. Either one of these is correct, but I prefer the first one. Because if I put the power inside, then that means I have to simplify. If I leave it outside, I don't have to simplify. So for me, I like the first one, the top one, not the bottom one, but they're both right, okay? So notice, for number 41, it says simplify 25y squared, the quantity of that, to the 3 halves. The 3 is my power, the 2 is my index. So this would be index of 2, 25y squared to the 3rd. Okay, now once you do that, then you do have to simplify a little bit. So what is the square root of 25? That's 5. What's the square root of y squared? Just y. So this is 5y to the 3rd. Well, 5 to the 3rd is 5 times 5 times 5. That's 25 times 5, which is 125. Y to the 3rd. Now, let me just make a real quick mention here. Sometimes this is all you need because nothing else simplifies, okay? But other times, you may have to go all the way to this point. Okay? Both answers are correct, but one of them is completely simplified. Okay? So as usual, which one should you do? Depends on your multiple choice, right? If multiple choice stops at that blue highlighted box, then that's what you put. If you don't see that blue highlighted box answer, but you see the one in the yellow, then that's where you go. Okay? So look at your multiple choices. They're always a good indication of how much work you should put in. So that's 41. 42, same question, just write it as a radical. Okay? Write it as a radical. So remember, since it's a fractional power, the 5 is my power, the 3 is my index. So this is index of 3.
Oh, can I go to my console?
Sorry?
My console? Can I go to my console?
Yeah.
Thank you.
Put a 5x on the inside, okay? And then put a parenthesis and a 5 out there. And you're done. Okay?
How would you know?
All right, so like we said before, that normally you're supposed to have a to the p over I equal to, this would be I root of a to the power of p. So notice for our problem, the letter p is a 5, okay? And then the 4 is my I, and the a is the 2x. So all I'm going to do is work backwards. I'm just going to write 2x, and then my power is a 5, my index is a 4, and that's it. That's all you got to do. Okay, so we're just rewriting radicals. That's all we're doing. Okay, and again, these are all questions from your test, just obviously a little changed, but you will see them like that. All right, this one. Simplify. So it looks like all these questions are kind of easy, I hope. So the square root of 16 we know. That's 4. And the square root of 5, we don't know. So then you're thinking, well, that's easy, right? But what don't they ever want to see? Yeah, we're not supposed to have radicals on the bottom. So remember, you multiply by the radical on the bottom. You want to get rid of it. Okay? So 4 times radical 5 is 4 radical 5. And radical 5 times radical 5 is 5. And you're done. Whenever you multiply the same radicals, then the square roots will go away, or cube roots, whatever, they'll go away. So, there you go. So 4 radical 5 over 5. And actually, correction, it's whenever you multiply the same square roots, it'll disappear. Not the same cube roots. You need 3 cube roots to make the cube root go away. But just 2 square roots. We okay with that one? All right. Here's another one. So we have negative 3 radical 32 times negative 3 radical 5. Now they want you to multiply, so that's exactly what I'm going to do. Some people like to simplify first. I kind of like to do that, but I always take one step first. My first step is always to multiply these things together, but not really multiply them completely. So notice negative 3 times negative 3 is 9. And then in here, I'm going to put 32 times 5. So that's what I mean by multiplying them, but not really multiplying them all. Because what I want to do is now ask myself, what can I break down these numbers into? One of these numbers has to have a nice square root, right? So obviously 5, I can't break it down anymore. But can I break down 32 into something that has 2 numbers, one of which is a very nice square root? Say again? 16 and what? 2. Yeah, that's perfect. So look, 9 square root of 16 times 2 times 5. Notice 2 and 5, they do not have square roots, but 16 has a square root of 4, right? This is a square root of 4. That means I get to take a 4 out. 9 times 4 is 36. And inside, 2 times 5 is 10. That's the way I do radicals. That, to me, that's the easiest way. Don't multiply 5 times 32, because then you get this huge number, right? No. Leave it as small things being multiplied together and break them down. Okay, little by little. To me, that's the best way to do these things. Some people will argue that what I should have done is broken down 32 immediately into 16 times 2 and then multiplied out and then put everything back together. It's the same thing. It's the same process. But to me, it just seems easier. Let's put them together first so that there's less distractions and then break stuff down. Okay? So that's 45. So notice 46. Same idea, just that I have to distribute, right? Negative 2 radical 2 times radical 6. And then plus a negative 2 radical 2 times radical 10. So I'm going to have to distribute this thing over. So if I do that, I get negative 2. Radical 2 times radical 6 is radical 12. Now, if you're wondering, well, wait a minute, why are you multiplying now but you didn't do it before? Because 2 times 6 is 12. That's easy. What's 32 times 5? Right? Like, that's not, bless you, that's not a, I got it, right? So to me, it's, why am I going to make such a big number? Let me keep it small, right? So 2 times 6, that's 12. I'm not worried about that. Negative 2 radical 20. All right, so far we're good, but I have to fix the radical 12 and the radical 20. So what 2 numbers give me a 12 that have a nice square root? 4 and 3, that's perfect because the 4 has a square root. What about 20? 4 and 5, good. So rewriting negative 2 square root of 4 times 3 minus 2 square root of 4 times 5. The 4 has a square root of 2, so it's going to come out. It's going to go out, and it's going to multiply the front number by a 2. So this will be negative 4 square root of 3 minus 4 square root of 5. And there's your answer. I mean, not to oversimplify these problems so far, but I think these problems have been a lot easier than the other previous 40 so far. Maybe I'm wrong. You might think, no, these have been harder. And again, everybody has a different opinion because it depends on what you like to do, what your brain does more naturally than other things. But for me, these seem to be kind of quick. They don't take very long to do. So hopefully they stay like that. Let's see. 47. So yeah, they're kind of sticking to that. Notice I have a square root of 12 and another square root of 12 and a square root of 5. You can combine square roots that have the same radicand. That's what the number inside is called, the radicand. Okay? So if they have the same radicand, you can combine them. So what I'm going to do is I'm going to combine this with this first. So negative 3 radical 12 plus 5 radical 12 is 2 radical 12 minus radical 5. Now notice the radical 5, there's nothing I can do with that. It's just square root of 5. I can't break it down. I can't take out the radical, nothing like that. But the 12, we just saw in the previous problem that 12 is 4 times 3, and the 4 has a nice square root. So let me rewrite that. That's 2 square root of 4 times 3 minus the square root of 5. The 4 has a nice square root. It's going to become a 2 when I take it out. So that becomes 4 radical 3 minus radical 5. All right, so that's my answer for 47. Any questions on that one? I'm just looking here. 48, 49. Notice this one will be real easy. That's a true or false question. But yeah, these are kind of getting a little easier. So, all right. This is where a calculator kind of helps you out. The square root of 256. Anybody know it? It's more than 10, less than 20. 256. It's 16. If you didn't know, just put it into your calculator. 16. What's the square root of x to the 4th? X squared, yeah. So there you go, done. Now if you're not sure how we got x squared, remember x to the 4th is just x times x times x times x. When you have it in a square root, you need pairs. So that's 2 pairs, so it's x squared. You're taking out 2 x's, xx, so that's x squared. Okay? All right? Well, here we go. Square root of 150. Well, 150 is 25 times 6. And the square root of 25 is 5. There is no square root to 6, so there's your answer. And our final problem. Here we go. True or false? False. Parallel lines do not have different slopes. Parallel lines have the same slope. Okay, so this is false. So that's 50 questions, guys. All 50 questions on your final. We've covered them. Again, not the same exact thing. So please do not memorize these problems and then say, oh, they never showed up, because they're not. Okay? But they are pretty much identical. Okay? Very close.